Question 6. Two graphs is given, and it is also given data that mx equal nx has no real root. It means mx and nx do not intersect. If it intersects, then there is a real root. What we can do, we'll draw a graph, two graph. So first of all, this one. This is y equal nx equal x minus 4. I'll write y equals, so okay, nx and then I will put mod value. So this is 4 0. This is minus 0 minus 4 become 0 4 and 3 times. So multiply by 3 all the values. So this is become 12, 0 12, and then everything is pushed by 6 up. So it's going to be something like this: 0 4 0. So this is 4 6 and 12 plus 6 18, 0 18. So this value is 4 6. Now this value, this graph mx equal minus 2x. So it's going to 0 0, y equal minus 2x graph. Then mx equal minus 2x plus k. So this is y equal minus 2x plus k. So this height is k. Now to intersect those two graphs, this graph and this graph, then this line should go through this, it should be parallel lines, everything. Four, 6. Now there is an intersection. Then the new k value is, now this is y equal minus 2x plus k. So this is the height of k. Now we need to find the range of possible values for k for not intersect. So from here to here, assume this value is alpha and this is 0. If k value less than this alpha value is, I will take that this is 0 alpha, less than alpha, what will happen? This line does not go through this graph, nx graph. For example, if line is here, then this graph and this line doesn't intersect. Now, to find the range, do the intersect area. To find the region, do not intersect with mx and nx. First of all, we consider intersect. Do not intersect. Let's forget about do not part. Let's consider intersect part. So, in this value, for alpha value, this graph y mx graph and this is nx graph is intersect at this point. Okay, I will stay with the value as k, then it is easy, not confusing. So this is the equation. So if this two graph intersect at this point, it means this 4 6 point is on this line. The 4 6 point is on satisfy this equation, and then we'll find the value for k. So that's the plan. So we want to find the k value, range for k value that do not intersect mx and nx. For that we assume, or we get the occasion that both graph intersect, and as a result 4 6 is on this line. It means 4 6 should satisfy this equation. Then we can find a k. We'll do that. Since assume mx equal nx has one real root. If it has a one real root, mean it intersect in one place. Then 4 6 point should lies on mx. Hence 4 6 should satisfy the equation mx. Hence we'll apply 4 6 value. Hence mx equal minus 2x plus k. So 4 6. So minus 2 times x is 4 plus k, and m we apply x is 4. What is m4 value? So this is 4, this is m4. m4 value is 6. 6 equal minus 2 times 8 4 k. So then 6 plus 8 14. When k equal 14, the graph has one root. It has a one root. I mean two graphs intersect each other. What will it mean? This height is 14. If k is 14, right? Those two graphs intersect. What will happen? K is 13. So then this is the height. It does not intersect. So basically, if k is less than 14, not equal to, if it is equal, there is a one root. If k is less than 14, we have a one root. We have no roots. If k equal 14, we have one root. No root. If k greater than 14, what will happen? Uh, two roots. There are two roots. Because k 14, then it will cut here and you can have two roots. So this equation number 7. So those are the two equations. This has one real root. We want to find the constant. So first of all, we draw this graph. Y equal x plus b. This is 0 b and this is minus b 0, and then y equal mod x plus b. So it is a reflection, this kind of graph. Then okay, tx, it is tx equal 2 times x plus b. It means all the y values multiplied by 2. So then it's going to be something like this. It is 0 2b, and yeah, this is as it is. Then tx 2x plus b minus 8. So we have to bring this graph by 8 units down, something like this. So this is going to be minus b and minus 8. So the graph is going to be something like this. So this point is minus b minus 8. And this is y negative gradient, minus x negative gradient, and minus 10. So 0 minus 10. So it's going through on this point because it has one real root. Now I want to find the value of b. So what is the equation of this one? Sx equal minus 10 minus x. Now we can see minus b minus 8 is on this line. S equal minus 10 minus x line. Hence, minus b minus 8 should satisfy this equation. Since minus b minus 8 on Sx, it should satisfy the equation Sx. Hence, we'll substitute. So this is Sx equal minus 10 minus x, and now Sx is, we'll put minus b, x equal minus b, s minus b equal minus 10 minus b. What is s minus b? So this is minus b, this is s minus b value is minus 8 minus 8 minus 10 equal minus b. So b equal minus 10 plus 8. So b equal minus 2. If we have the equation instead of sx y equal minus 10 minus x, simply you can write y value is minus 8 and minus 10, x value is minus b. I think I have to do a correction just now. I realize x value is minus b, so then minus b, which is plus b. So then b equal plus 10 minus 8, which is plus 2. So minus 10 plus, so b equal plus 2. If in this form y equal, not sx. Question number 8, we need to state the part a range of this one. So we want to find what is minimum and maximum. So we'll start with y equal x, then y equal x, y equal x minus 1. We'll bring one unit down, so this is going to be minus 0 minus 1. This is 1 0, and then y equal mod x minus 1. So then what will happen? This is 1 0 and this is 0 1. So this is mod, then 2 over 3 y equal 2 over 3 mod x minus 1. It means all the y values we multiply by 2 over 3. So 0, 2 over 3. Now it has to be something like this, because 2 over 3 is a fraction. So this is 0, 2 over 3. And still this is 1, 0. And then minus 7. So we'll bring the system to down by 7 unit, 1 minus 7, and yeah, that's enough. Okay, this is 2 over 3, so this point is 0, 2 over 3 minus 7, so that is this point. And now the graph is, so 1 minus 7. So minimum value of y is minimum value of hx, basically this is hx minus 7. Max of hx is infinity, hence range is minus 7 greater than or equal to hx. You can write like this as well. Part B, yh inverse x does not exist. because it's not one to one. Because H inverse X is not uh, not an one to one function. Now we have to give an example. So if you select this y value, so y equal alpha. So this is, let's say, A, and this value is B, and this is actually hx. Hx equal alpha. This is hx equal alpha line. Now we know, first of all, function. One to one is a function. Many to one is a function. But we know that one to many is not a function. Just to revise that. And to have an inverse, it should be one to one. Now we are going to show that this function is many to one. So we can see that for a value HA, we'll take A and B two value from the domain. In this is X is a real number. We take A and B and we'll consider HA. What is this coordinate? A, HA. This coordinate is BHB. And other one is HB. So what is HA is? H value A's value is alpha, because this is y equal alpha line, hx equal alpha line. So this is B alpha. In other way, right? B alpha, A alpha, this point. So hence HA also alpha, HB also alpha. Hence HX is many to one. Let's take or we'll write A is element of R and B is element of R. So A is then HA is alpha, so element of R, then HB is alpha. Hence AB both go to alpha. So HA is alpha, HB is alpha. Hence HX is a many to one function. Hence, hx is not a one-to-one function. Hence, H inverse is does not exist. If you don't want to write in terms of alpha, what you can do, find this point. In this point, y value is 0, and in this point also y value is 0, and this is x-axis, and this is hx. And when x equals 0, sorry, the hx equals 0 will work out. Hx equals 0, this line, then 0 equal to over third x minus 1 minus 7, so mod, then 2 over third mod x minus 1 equal 7, so x minus 1 mod equal 21 over 3 going up over 2, so then we have to consider 2 minus x minus 1 equal 21 over 7, and x minus 1 equal 21 over 7. So minus x plus 1, 21 over 7, or x equal 1 plus 21 over 7. So this is going to be 23rd over, not 7 actually, it's 2. 2. And then this is going to be minus x minus 1 plus 21 over 2, that is minus 19 over 2 minus x equal 19 over 2. This is plus and this is minus 19 over 2. So this is minus 9 over 2 and this is 23 over 2. Then h minus 19 over 2 equals 0, and h 23 over 2 equals 0. So the same argument here. So minus 19 over 2 is the element of R. Then h minus 19 over 2 is 0. Then 23 over 2 is the element of real numbers, and h 23 over 2 is 0. Hence hx is a many to one function, because minus 19 over 2 also 0, 23 also 0. Hence function is not one to one, hence h inverse does not exist. Part C, we have to solve the equation hx equal less than or equal to less than minus 6. So hx mean 2/3 x minus 1 minus 7 less than minus 6. So I will simplify a little bit this one. So 2/3 x minus 1 less than or equal to 1 minus 7 plus 7 minus 6, which is 1. So 2/3 x minus 1 less than 1. It means mod x minus 1 less than 3 over 2, 3 up, 2 down, and positive uh, 2, 2 over 3 positive. Because of that, I could multiply by 3 over 2. I mean, I multiply by positive value, so the inequality stay the same. It will only change if it's negative. So x minus 1. Now we have two options. One is negative x minus 1 less than 3 over 2. Other one is positive x minus 1 less than 3 over 2. So minus x minus 1 less than 3 over 2. So minus x less than 1 minus 3 over 2, which is uh, minus half. So I'll multiply by minus this equation, then x greater than half. 1 multiplied by minus 1. Or if you are not sure, another way of doing it, bring this one to here. So minus x plus half less 0, and minus x to other side, half x, x. So it's still the same thing. Now let's solve to this one. X is less than 1 plus 3 over 2. X equal 5 over 2. So x should be less than 5 over 2, and x should be greater than half. So it means x should be lies in between half x 5 by 2. I think minus times x, minus times minus positive. Okay, so then this is negative. This is positive and this is negative. It means this is positive half. Then when I multiply, this is negative. So this has to be negative. This is 1 and minus 7. And we want to find equation hx 2/3 x plus k has no solution. So this is a positive gradient, and I will draw like this, plus k. Um, so this is the k value, and we'll consider a situation 2/3 x if x minus 1 minus 7 2/3 x plus k has one root, one real root. So then this has to be parallel. And let's consider this k value. Hx equal 2/3 x plus k, and we'll find this k value. If this k value less than this value, then the graph going to lie somewhere here. Hence, it does not uh, intersect this one. Hx equal 2/3 x minus 7. If has one real root, then this 1 minus 7 should satisfy this equation. Then 1 minus 7 should satisfy Hx equal 2/3 x plus k. So when x equal 1, h1 equal 2/3 times 1 plus k. What is h1 now? So this is 1, this is h1 value. h1 is minus 7. So then minus 7 equal 2/3 plus k. So k equal minus 7 minus 2/3 k. So 23rd over 3 equal k. So if this line and graph intersect at one point, then this height is minus 23 over 3, which is 3 times minus 7.23 as a mixed number. What will happen? K value is minus 60. It means somewhere here it does not exist. What will happen? K value is minus 25. Minus 25 also less than this value. It means somewhere here it does not exist. Basically, K value is less than minus 23rd over 3, then there is this graph does not intersect. It means there is no real root. K greater than minus 23rd over 3, two real roots. K equal minus 20 over 3, one root, and k less than minus 23rd over 3, no roots. Question number 9. We need to find A. We can find because 0.4 point lies on Hx, and 0.4 should satisfy equation. So we'll apply when x equals 0, h0 equal a minus 2, 0 plus 3. What is h0? So this is 0, h0 point. So h0 is 4. 4 equal a minus 2 times mod 3. 4 equal a times mod 3 is 3. So 4 equals 6. A equal 4 plus 6 equal 10. So we can write the equation hs equal, I will write this part earlier, x plus 3 and a is plus 10 now. Part B, we want to find P and Q. So we'll find P first. If we have this graph, so hx equal minus x plus 3. Then hx equal mod x plus 3. Then hx equal 2 times x plus 3. So hs equal minus 2 times x plus 3. So hx equal minus 2 times x plus 3 plus 10. So this is a reflection. So we have y equal x plus 3 line. So we can tell that reflection of f axis on x axis where fx greater than 0. So then when we take the reflection, we will get this point. So this point become minus 3, 0. This is 0, 3. So minus 3, 0. Then this is a vertical stretch. Scalar factor 2. Then something like this. Then the scalar factor, then still the point is minus 3, 0. Then this is minus. It means turn all the y positive to negative, negative to positive. So then this is going to be a reflection on x-axis. Now this one become here and this one become here. So still minus 3, 0. And then the translation. Translation vertically by positive 10, then minus 10. So we gave a argument here. Hence, phi is minus 3, 10. Now we have to find Q point. So this axis is x-axis, mean this is hx. So this is hx equal 10 line. So x-axis mean hx equal 0 line. So we have to solve hx equal 0 and this one. So 1 and 2, from 1 and 2. 0 equal, okay, this is 1. Minus 2 x plus 3 plus 10. So we'll bring to other side. So minus 2x plus 3 equal minus 10. So x plus 3 mod equal minus positive 5. Now I will square this both side. X plus 3 square, 5 square. So x plus 3 equal 25. I am going to take the square root. X plus 3 equal plus or minus 5. You can simply write this one, x plus 3 is plus 5. So let's leave it, it's confusing if it is. So then there are two options, x plus 3 is 5 or x plus 3 is minus 5. So one is 2, another one is minus 2, minus 8. So now there are two options. As usual, one is x plus 3 equal 5 positive 1. Other one is negative. X plus 3 is 5. So x plus 3 is 5. X equal 2. And this is, I'll multiply by minus both sides. Then x plus 3 equal minus 5. So x equal minus 5 minus 3. X equal minus 8. So then this point should be positive 1. So 2, 0. So Q value is 2, 0. Part C, we have to solve these two equations. This is 1/3 x plus 6, so negative. Positive gradient with plus 6, 0, 4, somewhere it's going like this. So 2 points we have to look at. So from 1 and 3, from 1 and 3. So minus 2 x plus 3 plus 10 equal 1/3 x plus 6. So I will solve it. 10 means 6 plus 4. So 6 to 6 cancel out. So basically plus 3 plus 4 equal 1/3 x. Multiply by 3 minus 6. X plus 3 equal 12 x. Now we have to consider two options. One is positive, another one is negative here. So minus 6 x plus 3 plus 12 equal x. Other one is minus x plus 3 negative value plus 12 x. So minus x minus 18 plus 12 equal x. So 7x equal minus 6. So x equal minus 6 over 7. From here, this minus become positive. 6x plus 3 plus 12 equal x. 6x plus 18 plus 12 equal x. So this is 5x equal 18, 20, 30 minus 30. X equal minus 6. So those are the answers. Question number 10. When you look at this graph, you you will be able to tell that this x value is minus 3 and y value is positive 7. So when you look at this is V type graph, and then try to guess without drawing a whole sketch. So then maximum x mx, we have to look at the range. Okay, a range is for whole number line is 7. Minimum of mx is infinity minus. So then you can write minus infinity greater than mx greater than 7 and equal, or mx less than or equal to 7. The maximum value of y value is, or mx is 7. Part B, we have to solve these two equations as usual. So minus 4x plus 3 plus 7 equal 3 over 5x plus 2. So minus 4x plus 3 equal, this is plus 5, 3 over 5x. 7 minus 2 is 5. So then multiply by 5. So this is 20. X plus 3 plus 25 equal 3x. Multiply each terms by 5. Then two options we have. Minus 20, positive value. Other one is minus 20, then negative value of this one. So minus 20x minus 60 plus 25 equal 3x. So minus 23x equal minus 35. So x equal minus 30 over 23. So this is become positive, plus 25 over 3x, 20x plus 60 plus 25 equal 3x. So this is going to be 17x equal minus 85x equal minus 85 over 17, which is minus 5. Part C, k is constant, has two distinct roots. State the possible values for k. First of all, ms equal k, what kind of equation? So this is like mx equal 2, mx equal 4, something like that. What is this one? X-axis, mx equal 0. So those are the lines basically, mx equal. What will happen mx equal 7? So it goes to here. You have only one root. What will happen mx equal 8 or 9? No solution. What will happen mx equals 6? There are two solutions. Basically, by observation, you can see if mx less than 7, there are two points of intersection. Hence, k should be less than 7. those are parallel line to x-axis.